In this video, we're going to look at the cosine rule. So cosine rule is similar to the sine rule in that it applies to more commonly to non-right angle triangles. You could use it in right angle triangles, but for that you just use simple trig. And if we've got vertices A, B, and C, then we label the triangle in the same way. So side A is opposite angle A, side C is opposite angle C, and side B is opposite angle B. Now we use the cosine rule if we've got all three sides and we're looking for one of the angles, or if we've got two sides and the included angle and we're trying to find the third side. So two sides in the included angle would be the sides B and C and angle A, or B and A and angle C, or A and C and angle B. The formula is A squared equals B squared plus C squared minus 2BC cos A. Now we can manipulate this formula as well, so that if we were trying to find side B, we could write it as B squared equals, and then it's the other two sides, so it would be A squared plus C squared minus 2AC and then cos B. Okay, so the B squared matches up with the cos B. And we could do it for C as well. So C squared is going to be B squared plus A squared minus 2BA and then cos C. So again, we've got a C at the end and a C at the end. C at the start and C at the end. And then everything else is in terms of the other two letters. So one more, we could have P, Q, and R matched with angles P, Q, and R. And we could pick any of those. So let's say Q we're going to use. Then we'd have the Q squared is going to equal the other two. So P squared plus R squared minus 2PR and then cos Q. When we're using the formula, it's important that we have that it's A squared is B squared plus C squared minus 2BC cos A. So between the C and the cos, there is a multiplication, so we have to do this bit first of all. What we don't do, and what the common mistake would be, is we write it as B squared plus C squared minus 2BC, and then do the cos of A. So that's wrong. Okay, so it's B squared plus C squared minus, and then we do 2BC times the cos of A. Okay. Now we can also rearrange this for an angle, and for an angle it would be that the cos of A is equal to B squared plus C squared minus A squared over 2BC. What we have is that the angle we're looking for is the A, and then we're doing the other two sides squared and added together minus the angle A. So it's the A at the start and A at the end, and then 2BC. Similarly, in the previous form, we've got A squared and cos A at the end. So it's a very similar pattern. And we can apply this for P, Q, and R, or D, E, and F. So we could have the cos of D is going to be E squared plus F squared minus D squared over 2EF. So example 18, find X. So first thing we're going to do is label the sides. So let's go for A, B, and C. And then the small sides, or the small letters, are the sides opposite the angle A, angle B, and C. So we get that. And what we're looking for is C. So we've been given two sides and the included angle. So that means we're going to be using the cosine rule. Now, we're looking for side C. So we could manipulate the cosine rule to get C squared, and it's going to be the other two sides, so A squared plus B squared minus 2AB and then cos C. So we're trying to find side C, and we'll use angle C, and then it's the other two letters in place of the squared and the 2AB. So let's fill in the information. And we've got that X squared is going to equal 7 squared plus 9 squared minus 2 times 9 times 7 cos 41. So X squared is going to be 49 plus 81 minus 126 cos 41. So if we just put it into the calculator like that, we get that x squared equals 34.90659. So x then is going to be the square root of 34.90659. So x is 5.91 centimeters to 3 significant figures. Example 19, find AC. So we've got the vertices labelled, so we need to pick the sides. So the base is opposite angle A, so it's going to be side A. The 8.1 is opposite angle C, so it's side C. And the unknown length is side B. So we're trying to find AC, which is side B. So we're going to use the cosine rule, but it's going to be in terms of B. So it's B squared is equal to, then it's A squared plus C squared, because they're the other two sides, minus 2AC, and then it's going to be cos B. So the B's match up there. So we've got B squared and cos B. So let's put in what we have, and we'll have B squared is 6.5 squared plus 8.1 squared minus 2 times 6.5 times 8.1 cos 120. So that's B squared is equal to 107.86. Now that's found by squaring 6.5 and 8.1 and adding those together. Minus, so 2 times 6.5 times 8.1 is 105.3, and then it's cos 120. Now remember, we don't take those away, so we don't have 2.56 cos 120. So that's wrong, that's not what we do. We just put it into the calculator as it stands, and we get that B squared equals 160.36. Now that might seem a little bit odd because we've got a subtraction here and the answer's worked out to be bigger than 160, but whenever we do the cos of 120 it works out to be a negative, so these two negatives make a plus, and that's fine, that's perfect. Then we do the square root, so B is the square root of 160.36, and that gives us 12.663, so 12.7 centimeters to 3 significant figures. Example 20, find angle A. So that A with the circumflex above means angle A, and that's what we're looking to find, and we can see that because it's marked X. So let's label the sides. So we've got small a, small c, and small b, because they're each opposite angle A, B, and C. Now to find an angle, the cosine rule is the cos of A is going to be B squared plus C squared minus A squared over 2BC. Or we could have the variations of that, so it could be cos B equals A squared plus C squared minus B squared over 2AC, or cos C equals A squared plus B squared minus C squared over 2AB. So it's the same pattern every time, where you've got the cos of A, and then we've got A squared that we're taking away, cos of B, and we're taking away B squared, and cos of C, and we're taking away C squared, and then it's always the same pattern. So it's the other two sides squared and added together over twice of their product, squared and added together and twice their product, squared and added together and twice their product. But in this case we're trying to find A, so we'll use the first one. And putting in the information that we have, we've got the cos of X equals 6 squared plus 9 squared minus 8 squared over 2 times 6 times 9. So the cos of X equals 36 plus 81 minus 64 over 108. So the cos of X is 53 over 108. So X is cos to the minus 1 of 53 over 108, which is 60.6 degrees to 3 significant figures. Example 21, triangle ABC. So let's get a triangle drawn. BC is 7.92, AB is 5, and AC is 7.14. And we're trying to find angle C, so let's call that X. So for angle C, we're going to have the cost of C, so it's the other two sides, so A squared plus B squared minus C squared over the product, over twice the product of AB. We need to label our sides, small a, small b, and small c. Small a is the side opposite angle A, so that's 7.92. Small b is opposite angle B, so that's 7.14. And side C then is the 5. So let's put our values into the formula. So cos C is going to be 7.92 squared plus 7.14 squared minus 5 squared over 2 times 7.92 times 7.14. Cost of C then, so that's 0.78433. So I've just put those values into the calculator, and so press my fraction button and then squared 7.92 plus the square of 7.14 minus 5 squared over 2 times 7.92 times 7.14, and I get 0.78433. So C then is cost to the minus 1 of that, and putting that into your calculator, making sure your calculator is in degrees, so D or DEG at the top, and we get 38.3 degrees to 3 significant figures.